Okay, so I did a bunch of midterm prep for me, and I thought, hey, it might be, better to try to explain what I did, to explain to a group of people, to explain something, and if I can do that, I have mastered it for the most part. I already talked about this in the domain shenanigans. I think I still talked about this one. This one is fine. I think I stopped here, maybe. No, maybe not. But this one is basically saying getting this trace over here and getting this trace to get a 3D structure, 2D contour map, contour map. It's not working. Why is this not working? This should, in theory, what? Can I? Yeah, it should work. I don't understand. Yeah, it works now. Now the key thing over here is this. So key thing is this idea, and the same thing as the um, same over here with the concept. Put C over here to make it go up and down, but that could be also said as Z. Why can it be equal to Z? It's the same concept why we can call that a Y. When we have this function x squared plus c, we can consider this f x thing equal y because we can also say this plus y. It means that for a constant to shift the variables, you can get another variable by getting the other two uh, other variables to figure out the third variable. If there's three variables, you just need two variables to figure out the last one. If there's two variables, then you can figure out one variable to figure out the other one. That's the basic concept. Over here, we're starting with limits, which is a basic plug-in limit. Over here, as you can see, 2626 equals that. If you plug in, get an answer, you're done, like my high school teacher said. Over here, we have method substitution. Over here, you have u equals xy. So you turn that into a one-dimensional analysis, which we all know this analysis. If you go down over here, it equals 1, basically. And that equals negative half. Very simple concept. It's law hop again. Very simple. Well, here's DNE because 0x, if I do this, equals 0, 0. Oh no, 0, 0 equals 0. What do I do? Well, that doesn't tell me anything. If there were different numbers, it tells me that it's no longer, it's DNE, but it doesn't tell me it's DNE right now because without 0, 0 means nothing. They're the same number, it means nothing yet. So it's easier to just prove it. So I do y if x equal y squared because any variable here plug into here must be going to the same point, but this does not give you the same point and it goes to a half. Therefore, the question is DNE. Um, yeah, basic concepts. It's more of a definition style question there, I think. Which is pretty good. That's one of the best questions. And these questions, you know, this question. This is just basic limit ideas. Now this is where it gets harder, where you do negative and 2x, which equals positive 7. Do this. Alternatively, you could do mx, and then do y, some fancy y shenanigans to figure all this out, to see that m does inevitably conquers all the equations offered. I don't remember if that's actually true. I think actually this fails. And now looking back at it, I think it fails. What you need to look at is the um, this idea over here, which is so much simpler. X and comma 2x. I think you can even do this, and then to say that this is 0. Oh, you can't do 0. Excuse me. So you have to do 2x. Yeah, you have to, don't you? 2x squared, x2, x squared. Yeah, you have to do that. You have to use this method. That's funny. Over here, we're gonna start with this one. So I recommend you get a cheat sheet, which is everyone's allowed one cheat sheet in our test because memorizing this thing is horseshit in our modern day. Um, I would recommend in your cheat sheet to write this. No, if the numerator here it is. N is a numerator top, okay, and then the denominator is a bottom number. Replace the numerator with something bigger while keeping the denominator same will constitute a limit definition. Other way is replacing the denominator with a smaller while keeping the numerator same, which would institute a limit. Yeah. So why would you need that? A few of these questions definitely need this. Like this one over here, I transformed to here because this is smaller than the domain. It's a rule you have to memorize. It is something that you learn 20A, and you forget about it until now. Basically, you forget about it for a long time. It's a 20A concept that no one gives a crap about. Calculus 1, no one gives a crap about until later on, and still you don't really care crap about because it's not an absolute rule. Sometimes it doesn't even work. So yeah. Over here is the DNE, A over here, same concept with the y squared. It's literally the same thing over here, just a little less, just a different number, just a different letter. Over here, I did a similar concept again, one in A, which is a DNE. Number C is which is confusing, where it's actually equal to 0. It has some no way I refuse. Some fancy rules of absolute value. So there's a way to do absolute value because if you think about it, absolute value means -2, +1 with the absolute value over here. It gets complicated there, but that's the basic concept over here. This one also has this method too. I do not like this method, as most people can tell by me saying, go to the polar. Polar is so much easier. I don't really give a fuck about this method. This is trash. I'd rather do polar than doing this thing. Because polar is number one, in my opinion. All right, this question is really awesome. This is over here. One thing I do not like is a sec integral. You need to memorize that or write down a cheat sheet. Yay! Remember your sec rules. Your sec rules, or just write in a cheat sheet. I recommend you write in a cheat sheet. Also, remember your LN1 rule because your teacher asks for the most simple definition usually, which means you need to memorize that LN1 is called zero. Zero. Understand what I mean? Understand. Say it again. LN1 equals 0. You gotta memorize that at this point in time. Um, yeah, it's just a pain in the ass. And then over here is a parameterization thing, which I don't really give a fuck about, but I had to do anyways. So this is the MX way, which gets you this form, which M is defining the whole thing. So DNE is the answer. Over here, I refuse the deal. So this is getting a tangent plane, getting a partial derivative y, and plugging it into equation form. So this is fx, refuse the deal y, and this is fx y, plug in by the point to refuse 1. As I said, f equals this. I refuse the deal. What I mean by that is this thing is can be if you have x and y, you can figure out the second everything else with the known variables outside of the context. Therefore, this is correct. That was the most long way to say it's correct. Over here is a pain in the ass question that no one gives a crap about, but so yeah, we were doing this part, which you can clearly see is just a bunch of algebra, bunch of complex algebra actually, but nonetheless, it's just algebra at the end of the day. It might be a little difficult, but that's all this part is. Over here is a little tricky, but it's basically this portion the same, this portion the same. This thing cools down, heats up because it's +2, +3, +4. Kind of a basic question if you know what you're doing. I wouldn't put too much thought into that. Although, yeah, yeah, I don't think so. Right, so next part of the question is part two, which start from here, linear approximation. We need z first, which actually, did I even talk about the idea of getting tangent this part, which is getting z equal? I think I did. Over here is the same concept, x y, this one. And over here is fx and fy. Just keep on following through to get the point over here. It's kind of funny because that is a plane equation, if you didn't know. Similar to that, although the difference is this part over here. That shows something different. But over here, this is just basic. And then this is the hard part. Going over here, and then over here lastly, which is because du pv, no, FPV, right? So there's a magnitude of FP by the cosine of an angle, but usually that's called can be unit vector, so you can literally say unit vector by square root, which is what this is, which is the same thing as saying cosine. While because the unit vector is one, it just get rid of that. Pretty basic concept. Du concept. That's funny. Over here, a little harder question, but honestly, she'll get it if you know that the n must equal the tangent parallel to this portion. So this is how you do it, getting these two angles by getting the a, which would be plus or minus this, plug it back to over here. Say, this portion is, oh yeah, this is this shenanigans, which is a pain in the butt. You do this portion, which is this over here. Then you do this portion over here, which is over here. You're getting that to over here, this format. I think I did something wrong here. Why did the wait? Did I do it right? Yeah, I did it right. dy. Over here is increasing because of this change over here. 20 slope is increasing, and over here is this is just basic nonsense over here. So sine of f y at point A is always increasing over here because no, it's actually decreasing over here. It should be negative because it's lowering. Over here it should be positive, very positive. Over here it should be positive. Over here it should be negative. Over here not a lot of change happens. Over here we get into our first the DNE. It should be DNE. I think. Oh, is it not DNE? No, it's DNE. Why is this not DNE? Yeah, it should be DNE because zero is the same thing. They're the same question, so this should be DNE too. I don't know why it's not DNE, but you can obviously tell it's DNE by um, plugging in sine with zero, no x, no y, which is zero, which is impossible. Here on the bottom, um, you can do a bunch of other stuff, but zero at the bottom, that just doesn't work. And then you can try doing x comma 0 and 0 comma y if you want. It doesn't really matter. As you know about the cosine sine rule, it really doesn't matter. Over here is, oh, that's a tricky one. Getting these two, the other sides, to make this into a 0. So asking, you multiply some infinity number to 0 is fine. Over here we have polar equation. So I think I talked about polar. It's just polar, and then r squared equals 0, so that's fine. That's the how you shape it with the cos section a squared plus y squared. Over here is another one, very simple one. And then this is a little confusing. You do the conjunction. I think kind of clear obviously on that to get two. I'm gonna go down fast. I think you look at it more, but let me go to the harder ones now. These are pretty simple. Yeah, these are harder ones. So r cosine sine and the r is squared by turn it to one because it's like that, and then just cancel those two out. Cancel one of them out, and then get r which equals 0. Do not do this way. This way is false. So I mean you can do it, but it's really difficult. You do it a difficult way. Oh, this doesn't work because this shows a case where r doesn't work because r squared is cancelled by two r's over there. So you have to use now the other method, showing a squeeze theorem failing and doing another method is working. But for the most part, squeeze theorem is so powerful that it doesn't really matter. Look here, it works. Squeeze theorem. Over here, what are you doing? Derivative of x, then y, then z is what it's doing. Pain in the ass question. It's a lot of computation. I'm going fast. Oh, this is 70. Let's skip that because you don't need it. This one too. Part 3. So this one over here is a circle question. No, it's a not circle question. It's a parameterization question. Why is this all the way here? Well, it doesn't really matter. We'll call 1, which is, we don't really care about that question. The same question over here. The same style question, but you need to do a cross product instead, which sucks. Um, this one also same type of question. Over here, same type of question. This is a tricky one. So you get the integral of this, integral of this, integral of this, and you see that zx is 2 times zx plus y. Over here, this does not equal, so just integral of both of them. That doesn't match, so you can't have those two. That's just a lot of derivatives, and this is the hardest one because you use physics. So looking for speed, and you need to know about WT over here because that's how physics works. Over here, you could have chose R. I think R is much easier, in my opinion. Another case of D&E. Another case that, it's a split multiplication, so you need to split into two different variables to get 0 equal to 0. That's a trick question. Over here, you can get D&E because of Math 20C, 20A. Over here, we don't need to know about it because it's not really important to our the 20C theories. Over here, crossing it out to figure out that's 0. You can look over again, but it's the same concept. It's very similar. This one is a little complicated, but I guess I could talk a little bit of it. You split this one into two portions over here, getting a 0 and a 1, so 0. The second question is a really complicated one, so we just have to figure out 2 points where it equals two different numbers. So I chose two different numbers and figured out they're different. Same with the bottom one. And that's just a pain in the ass to do, honestly. But you eventually figure out that they're different numbers. Over here, there's one because obvious, and then arc length parameterization is kind of confusing. But integral of t to 0, it's just doing this. And another parameterization just because I can do it.